All right, everyone. So today we are going to be talking about large numbers and how we can estimate large numbers with knowing only a small amount of information. So before we embark on this endeavor, we're going to be talking about concepts we've seen since grade school, throughout grade school, um, and that we've even gone over in our time together. And that concept is going to be area. So we know that area is simply the space um, occupied in by a flat object. Okay, so formula varies based on what object we're looking at, but in general the object tends to be rectangle or a square. And we know the area of a rectangle or a square to be length times width. So the first question I would like to ask you all is, what is the area of a square that is 5 feet long by 5 feet wide? Okay, so I love to draw pictures, so I've got a 5 feet long and 5 feet wide. Of course, because these numbers match, I definitely know I have a square, so the problem didn't even have to tell me. Okay, and so I really encourage you to not do this in your head, and here's why. Because when you write out the problem, you remember that there's units involved. So instead of saying just 25, which a lot of us are inclined to say, we're going to remember that we're also multiplying feet by feet, right, which becomes feet squared. So the area of a square that is 5 feet long by 5 feet wide is 25 feet squared. So pause the video here if you need time to go over this concept. So I need you to remember that number because we are going to look at it in this slide. So we're going to actually try to count the number of people we could possibly fit into this square. But in order to figure that out, we have to have an assumption or a rule of thumb to figure out a rule of thumb for how much space a person occupies. So the rule of thumb for that is that each person occupies 2.5 square feet. Okay, don't be confused that I wrote square feet. It's the same thing as saying feet squared. So with this information, now I can estimate how many people fit into the square from Q1. Right, so I have this square that's 5 by 5. And I'm trying to figure out how many people I can fit into this square. So just like if I said I have $10 and 5 friends, how much money does each friend get if the money is divided equally? That's a parallel example of exactly what we're doing here, right? So if I had $10 and I'm dividing it equally among 5 friends, they get $2 each. So if I have a square, so I have this total area, and I'm going to divide it by the area per person. So that's going to be, I had 25 feet squared, and each person occupies 2.5 feet squared per person. It's nice that we see the units because then we see it cancels. And we can actually do this in our head, right? 25 divided by 2.5, move the decimal over, I'm left with 10 people. Nice. So we figured out that that square has an area of 25 feet squared. We figured out that we can fit 10 people in it if we're using our rule of thumb. Let's go on to the next slide. Pause here if you need more time. Okay, so now we're going to try to figure out the ratio of the number of people to the area of the box, which should be an answer we already know, but we're just going to look at it so that we truly understand. So number one, the definition of a ratio is the comparison of two values expressed as a quotient. Oftentimes you see ratios expressed in two ways. One is with a colon. Okay, so like that. And the second way is as a fraction. So this is a colon, and there's a fraction. So let's say I have one girl to two boys. That's the same thing as saying one girl to two boys. Okay. Example, like if I was only teaching 3 kids. Okay, so now I want to see what is the ratio of the number of people to the area. So the number of people, so notice how it says 2. That 2 is the colon or fraction we see above. So the number of people, I'm going to do it in fraction form just because I like it a little bit more. The number of people to the area of the box square. I should say. So we know that the number of people, we know that there's 10 people, and I know that the area of the square is 25 feet squared. And naturally, well, sure, we could reduce this down. So this would be, let's say we had divided by 5 each, that would be 5 people per every 2 people. Let me erase that. Oops. Moving too quickly. So that means I have 2 people for every 5 feet squared. Okay. And then if I thought about this in my head, I think about, okay, so 5. That's my whole, right? So that means if I have 100 as my whole and I divide it into 5 parts, that's going to be 20 times 2 is 40. So I'd have 0.4 people. So this is going to be, so you can leave it as this, or if you want, you can put it in a ratio. So that's 2 people per 5 feet squared. Or you can actually just divide it out. So I would get 2 divided by 5 is 0.4 people per feet squared. 0.4 people per feet squared. So definitely take a moment to look at that. And it should make sense, right? If we have if each person occupies 2.5 feet squared, each person, it makes sense that if we're looking at just a single amount of foot squared, it's about 0.4, right? Because one whole person should come out to be 2.5 feet squared. But in order to just look at 1 foot squared, right, that's what we have there, 1 foot squared, it's equivalent to 0.4 of a person, which is not really possible. So it's better to leave it in that form. Okay, so now we're going to actually be doing some estimations. I want you to estimate so let's say it's Thanksgiving and we're at the Macy's Day Parade in New York City. I want you to estimate the number of people in a crowd for people that are watching a parade along a 1-mile section route that is 10 feet deep. So I think it's always good to kind of draw out what I'm reading here. So this is 1 mile, and it is 10 feet deep. So I have people all here watching the parade go by. Okay, so in order to figure this out, we have an issue. And that issue is that I have a conflict of units. So we need to make an assumption in order to move forward. And that assumption is that number one, that each person equals 2.5 feet squared of area. And then two, that 1 mile equals 5,280 feet. So now I feel a lot better because I can answer this problem. Okay, so the first thing I want to do is so let's look at our steps to solve. Steps to solve. I want to first figure out the area that I'm dealing with here, the area of space that I have. So that's pretty easy now that I have this information. I'm going to multiply length times width, so 5,280 feet times 10 feet. That's nice because I don't have to do any math. I'm just going to add a 0. So that's 552,800 feet squared. That is the area that I am occupying. And now the easy part, step 2, is just figuring out the number of people. So just like we did in our smaller example, I'm going to take my total area and divide it by the area occupied per person, which means I get 52,800 feet squared over 2.5 feet squared. You could try to estimate this. Here's the estimation. So I could take this down to 52,000. Yeah, I could take that down to 52,000 and divide it by 2. Or I could take it up to 54,000. Let me see. 54. Yeah. 54,000 and raise this up to 3. So if I did it the first way, 52,000 divided by 2. So I'm just going to put that on the side here. So options for mental math. No, you don't have to know this. I could do 52K divided by 2 feet. Or I could do 54K So in the first one, I would get about 26,000 feet squared. And in the second one, I would get about, let me see, 3, so that'd be 1 with, subtract that down, 24, so that'd be 18,000. So I got about a lower limit and an upper limit. So I'm going to expect my final answer to be probably somewhere in between, right? So I have this is my lower. Let me see if I get a different color. 10. So this is going to be my, it's called the lower limit. This is going to be my upper limit. So I'm expecting it to be somewhere in between. And indeed, when I carry out the calculation, I get 21,120 people. Awesome. So that does confirm our mental math thoughts. And it makes sense too. Goodness me, can you imagine? Well, also that's if this crowd was each person was right next to each other. So I should actually add that to our list of assumptions here. Let me put that 3. That's assuming each person is standing right next to each other. So it'd be like 2.5 feet squared, 2.5 feet squared, right? So that's each person. So that would be a really crowded parade, and I would not like to be there. And it does indeed sound like the Macy's Thanksgiving Day Parade, because that always looks packed. So what we have been doing is actually answering Fermi questions. Well, in particular, the last one. Because Fermi questions require estimations of physical quantities to produce an answer. So logical, in order to get these answers, right, and these accurate estimations, Fermi was an Italian physicist who was known for being incredibly accurate. So in order for him to be very accurate with very little information, we have to have logical assumptions about the situation that allows us to reach an estimate to an order of magnitude. That allows us to reach an estimate to an order of magnitude. Usually it's a power of 10. Usually it's a power of 10. So here's what I want you to do before I see you all next. I want you to estimate one of the following situations and type your response in the Microsoft form I will provide. I want you to pick one of the following and estimate. And I need assumptions stated, really for all of them. So the first one is the cost to raise a child. The second is what has more value, a pile of pennies equal to your weight or a pile of quarters equal to your height, which doesn't really need assumptions, although you should probably state the assumptions, which is the value of a quarter and the value of a penny. And then the number 3 is the gallons of gas cars use each year in the US. So it'd be good, like I would use the assumption off my car. So I have a Honda Civic and it takes about 11 gallons and I fill up every 2 weeks. And so I'd go off like that. Mine's probably going to be the lower end of gallons of gas used by cars. It'd be good to take a car that's probably somewhere in the middle. A car that's not super luxury or sport that requires a lot of gas and uses it quickly, and also not very, very fuel efficient, right? Because I want an average of all of them together. So go ahead and do that. Good luck, and let me know if you need anything. Thanks, y'all.